All right, welcome back. We're going to look at the second page of the Unit 11 test review. It says, find the area and perimeter of the following parallelograms, round to the nearest tenth if necessary. So for number 11, remember when we're finding the area of a parallelogram, it's always A equals base times the height, where the base and the height will always be perpendicular to each other. And where the perimeter, what we need to do is we just add up all the sides. So this first example is really straightforward. I can just say A equals BH, right? And the base here is 18 and the height will be 16. So I can just put 18 times 16, which will give me 288 square feet. Now for the perimeter, we know with the parallelogram that opposite sides are congruent. So if this side is 18, then this side is 18, so 18 feet. And if this side is 20 feet, then we know that this side is also 20 feet. So then I can use my, I can figure out the perimeter by just adding up all the sides. So I can do 2 times 20 plus 2 times 18, and that's just going to give me 76 feet. So with perimeter, we don't square the unit, we just leave it as is. So for the perimeter, we just write 76 feet. For number 12, we have a parallelogram. We know that this side length is 23, and this side, so this side, is 23 as well. But we don't know what these two side lengths are. And they're congruent to each other because, remember, opposite sides are congruent. So I'm looking at this little right triangle here. How do I know this is a right triangle? Well, this segment is perpendicular to that segment. So they intersect at a 90-degree angle. Okay, so look, we have 45, 90, then this must be 45 as well. So using my special right triangles across from 45 degrees, this is my A value. My A value is 5. It's the same thing for this angle. It's 45 across from the 45-degree angle. This side length here, which is my height, is also 5. And then look, A root 2. So this is 5, 5. So across from the 90-degree angle, that's my A root 2 or 5 root 2, okay? So here is 5, and this is 5 root 2. So if that side length is 5 root 2, then this side length is 5 root 2. So I'm going to go ahead and find the area now, which is going to be A equals base times the height. The base and the height will be perpendicular to each other. So the base here is what? 23? So 23. And this is my height, which is 5. So 23 times 5 is 115 square meters. For the perimeter, all I'm doing is just adding up all the sides. So P equals 23 plus 23 plus 5 root 2 plus 5 root 2. 23 plus 23, that is 46. And then 5 root 2 plus 5 root 2 is going to give you 10 root 2. So I'm just counting the number of root 2's there are right now. So if I have 5 root 2 plus 5 root 2, how many root 2's are there? Well, there are 10 of them. So you write 10 times the square root of 2. So this you need to put into your calculator. You can't just say it's 56 root 2. You actually have to put these numbers into your calculator, and you're definitely going to get a decimal for your answer in terms of the perimeter. So 46, which I already did on the calculator, plus 10 times the square root of 2 is 60.1, approximately. So this is approximately 60.1 what? Meters. Okay, we just write meters because we're dealing with perimeter. Number 13, we still have the parallelogram. The formula for that is A equals base times the height. The base and the height are perpendicular to each other. And what do we have here? So that's 12 centimeters. This is 12 centimeters. That's 20 centimeters. This is 20 centimeters, right? So we have the base, which is 12. But we don't know what the height is. So I can see that we have a right triangle here. So I have 60, 90, and this is 30. So across from the 30-degree angle, this side here is A. This side here is A. Across from the 60-degree angle, this side here is A root 3. And then across from the 90-degree angle, this side is the hypotenuse, and we set the hypotenuse equal to 2A. So I'm looking at this thing here. I have 2A equals 20. If I divide both sides by 2, A is equal to 10. So this side is 10, and this height, the height here, is 10 root 3. So let me go ahead and redraw this figure real quickly. I have 12, 12, 20, 20, and the height is 10 root 3. So then my height is 10 root 3. So I can go ahead and multiply the coefficient to the coefficient. I have 12 times 10, which is 120 root 3. 120 times the square root of 3 is approximately 207.8 centimeters squared. Okay, so that's my first answer. For the perimeter, I'm just adding up all the sides. I have 12 plus 12, or 2 times 12, plus 2 times 20. So then that is 24 plus 40, so you have 64. The perimeter is 64 centimeters long. Number 14, I have a parallelogram, and I can see that these two segments are perpendicular to each other, so that means we have a 90-degree angle here. So I have 1690, then this must be 30. So then across from 30 degrees, this is A, and this is going to be A root 3, and this is just going to be 2A. So I'm looking at this thing here, 2A is equal to 8. If I divide both sides by 2, I have A equals 4. So A is 4, this side is 4, and this side is 4 root 3. So the height is 4 root 3, so I can figure out the area. So A equals, the base is 10, and the height is 4 root 3. So then 10 times 4 is 40, so 40 root 3, which is approximately 69.3 square meters. For the perimeter, well, look, this is 10, this is 10, this is 8, this is 8. So the perimeter is 10 plus 10, which is 20, plus 8 plus 8, which is 16. So 20 plus 16 is 36 meters. Number 15, find the area of the following trapezoids. The formula that you need to know is A equals 1/2 times the quantity of the first base plus the second base multiplied by the height. So for number 15, the base is, or our first base is 5. So I'm going to write 1/2 times the quantity of 5 plus 9 times the height, which is 3. So 1/2 of 14 times 3, a half of 14 is 7. So 7 times 3 is 21. 21 what? 21 centimeters squared. Number 16, using the same formula here, I have A equals my first base. And yes, it looks like a weird trapezoid, but it's still a trapezoid, right? It's given to you. I have A equals 1/2. The first base is 12 plus 18 times the height. It's perpendicular to the two bases here, right? So our height is 8. So then I have 1/2 of 30 times 8. A half of 30 is 15. 15 times 8 is 120 square millimeters. Number 17, find the area of the following composite figures, which means that you look at the shapes, you determine which shapes you have, and then you're going to add up the areas of all the shapes that you currently see. So right now, I'm looking at number 17. I see we have a rectangle, so we're going to figure out the area of the rectangle. And I notice that we have a triangle, so I'm going to write area of triangle there. Now, since we have a rectangle and I'm trying to find the area of that, the formula is just base times the height, and the area formula for a triangle is 1/2 base times the height. Now, the base of the rectangle, we can call it 12, and the height, since it's perpendicular to the 12, is 10. So then the area of a rectangle is 120. For our triangle, we need the base, right? We need the base. So the base is 12, right? And then the height, well, how long is the height? Well, if we know that this whole thing is 16 and this here is 10, then what's left over? Well, 16 minus 10 is 6, so the height of that triangle is 6. So I have 1/2 times 12 times 6. Half of 12 is 6, so 6 times 6 is 36. So now I'm going to go ahead. I'm going to add up our figures together. So 120 plus 36, you get 156 square centimeters. That's your answer for number 17. For number 18, we have 3 semicircles, right? So I'm going to write A sub 3 semicircles, okay? And then our next figure here is a trapezoid. So A trapezoid. So we know the area of a circle. So the area of a circle is always pi r squared. But with a semicircle, you need to divide the area by 2. So pi r squared divided by 2. But since we have 3 semicircles, we just simply say 3 times pi r squared all over 2. All right. So the area of a trapezoid is 1/2 the first base plus the second base multiplied by the height. Let's work with the trapezoid first. Well, look, we know that this here is 3 inches. And, oh, I can see those tick marks too, right? So this side, or not this side, or yes, this side, and this side, they're all congruent to each other. So if this is 3, then this is 3, and this is 3. Put it over here. So in total, our first base is 9. So in total, our first base is 9. Okay? So I have 1/2 the first base, which is, again, 9, plus the second base, that's 6. And then I multiply by the height, which, again, is 6. So I have 1/2 of 15 times 6. I can just simply say 1/2 of 6 is 3. 3 times 15 is 45. So the area of a trapezoid is 45. And then trying to figure out the area of, let's say, 1 semicircle. And then I need to multiply that by 3 because there are 3 semicircles in total, right? So 3 times pi. The radius is not 3, right? It's from the center to the circle, or to the semicircle. So our radius is actually 1.5. So radius is 1.5. So pi times 1.5 quantity squared all over 2. So we get, let's see, what do we get here? I'm gonna go ahead and show you how to put this into your calculator because we definitely need to do that, okay? So let's get the calculator out. So I have 1.5 raise it to the second power. It's 2.25, and we're dividing this by 2. Okay, we'll slap on the pi later. Okay, so I have 3 times 1.125 pi. So 3 times 1.125 is 3.375, and we need to slap on the pi at the end here, okay? So we have our area of 3 semicircles and the area of our trapezoid, so I can just say A sub 3 semicircles plus our trapezoid is equal to 3.375 pi plus 45. And we're just going to round for this one. And yes, we're going to be adding. So when we add, it's okay to include the pi into your calculation. So 3.375 seconds, arrow, you get your little pi symbol, plus 45, and you get, we're going to round, we can round whenever we want, or we can round to however we want it, because it doesn't say how you should round it. It's approximately 55.6. We're going to round to the nearest tenth here. So 55.6 square inches, okay? So that is our second page of our Unit 11 test review.